This is an example of a building automation and controls, a little example problem to work on. It includes a specification and some solutions and is very good practice for a final exam where you might have to make a points database for a direct digital control system using ASHRAE's BACnet architecture. In this particular question, it's a fan coil unit or an FCU. It has a hot water coil that you can, put some control on. It has a chilled water coil too. You could put some control on that to, bring to cool a room. It has a two position, very simple two position. It's either open or closed outdoor air damper. And it has a fan. So you can control the hot water coil, chilled water coil, outdoor air temperature, or outdoor air damper, and a fan. There's a space-mounted temperature sensor, so that is a wireless temperature sensor. It has some adjustment buttons to adjust the set point of the temperature. The control of this this fan coil unit will be done with GDC control with BACnet standard architecture. There should be some alarms programmed here. If the fan fails, so if you ask for the status of the fan, but the fan says, nope, status is nothing, there's no current running to the fan, then it should have an alarm. And there should be an alarm for whether the space temperature is 2 degrees above or below the set point when it's occupied. On the LCD of the local display, it will display the temperature, the space temperature, discharge air temperature, fan command, heating control valve position, outdoor air temperature status, fan status, and CCV position. These should all be displayed on the surface mount wireless temperature sensor. And the only thing available to adjust is the set point. The fan coil unit should operate in occupied mode according to a schedule listed here. It has some holiday. It'll be when it's unoccupied, then it can be considered on a holiday schedule. When it's occupied, then it's within these hours. When you're occupied, then the fan coil unit should be operating. The fan status should be proven with a current switch, which is a current transducer, just to detect if that fan is actually working. When it is occupied, again, the fan status has been proven that it's on. The fan coil, the outdoor air damper should be open. The water, the heating control valve, and the cold chilling control valve should be controlled on some sort of controller, PID controller, to be plus or minus 1 degree Celsius of the set point. Otherwise, the heating cool valve and cooling cool valve shall be according to the occupied mode. When it's unoccupied, like vacation mode or any other times, or when the motion sensor does not detect motion, then it should stay in occupied mode until 10 minutes after no longer occupied. And then it specifies the fan control and the temperature for unoccupied mode here. All right, so let's go to that unoccupied mode. the fan will be disabled, and during unoccupied mode, it should stay within this temperature range. So we have a difference there. Now the question is just saying, oh, and this is what the system looks like. There is return air. This is a typical HVAC system. Return air from the room comes here. Outside air comes in here through this on-off damper. And this is your fan. This is the fan. And this is your heating. And this is your cooling. And these ones are coils, not valves. So all you have to do is list all of the control points, list the hard points, list the soft points required to satisfy that spec. Remember to use the proper nomenclature from the appendix. Control points are inputs, outputs, and variables. Identify where these points are located on the fan control unit drawing. So excellent example problem. And here's a chart for you. Here's a chart for you to try to think, what are the inputs? What are the outputs? What are the variables? Outputs are commands. It's when you tell it to do something. Well, I'm probably going to command it to turn on the heating coil, probably going to command it to turn on the cooling coil, probably going to command it to turn on the outside air damper. And my inputs are questions. I probably have to ask, what is the outside air temperature? Probably have to ask, what is the current room temperature? Probably have to ask, hey, is that fan working? And then I need some variables in here. My variables, it talked a little bit about alarms being set. It talked about schedules. You should probably make some, some charts of the fan status so that we can see that the fan's always on, and probably make some pictures like a system diagram as well. And then you can reorganize all of your points into a points database, put them into inputs, outputs, variables, control loops, schedules, runtime logs, trend logs, etc. So that's a really nice example of a simple unit that you can go through and say, there's probably about 10 points in this system for this one little piece of what's probably a larger system. If one were to give a final exam question about planning a points database, it would be similar, maybe a different component, but a component that also would have some inputs, some outputs, some things to change, some variables, some schedules, control loops, etc. So really nice to study from.